Question 9. In the diagram, PT is equal to 4 cm, TS equal to 6 cm, PQ equal to 6 cm, and angle SPRO equal to 30 degrees. Calculate correct to the nearest whole number, A part of it, SRO, B part, area of TQROS. Solution. In this diagram, you have two triangles, triangle PTQ and triangle PSR. So by properties of similar triangles, in the first triangle, the ratio of PT to TQ is equal to ratio of PS to SR. We know PT. For us to get SR, because we know PS, we must get TQ. So this is TQ, and we are to consider the first triangle PTQ, and we are to go by cosine rule because you have two sides and an included angle. The side you are looking for, the angle facing that side is given to you, so you go by cosine rule, where you have TQ squared equal to PT squared plus PQ squared minus 2 times the product of the two sides and cos 30 degrees. So you have TQ squared equal to 4 squared plus 6 squared minus 2 times 4 times 6 cos 30 degrees is 0.6880. So TQ squared is equal to, you have 16 plus 36 minus 48 times the angle. If you add together and multiply, you have 52 minus 41.58568. If you subtract, you have 10.432. To get TQ, you take the square root of 10.432, and that is approximately 3.23 centimeters. So back to this ratio. So you have 4 over 3.23 equal to 10 over SR. If you make SR the subject, you have 10 times 3.23 divided by 4, and that is 8.075. If you multiply first, you get this. If you divide, you get this. To the nearest whole number, you have 8 centimeters. B part of question 9 should find the area of TQROS. TQROS is a quadrilateral, precisely trapezium. So we have TQROSR. You can see that TQ is parallel to SR. So area of a trapezium is 1 over 2 sum of parallel sides, that is TQ plus SR times the height. So we need to produce the height and look for it. So already we know TS. We know TS. For us to get the height, since this length is unknown, you have to get this angle. Now, by properties of similar triangle, you cannot get this angle until you get this angle, because both angles are equal. So once we get theta, automatically we have alpha, and we can get the height. So you have alpha equal to theta, property of similar triangle. Now to get theta, you have this side is known, facing theta. Now 30 is known, and we know TQ as 8, so we can use, okay, no, we know TQ as 3.23. SRO is 8, so we know TQ. So you know when you have two sides and one angle and you want to get another angle, you use sine rule. So we have TQ over sine 30 degrees. This is TQ and the angle facing it, then equal to PQ, which is 6 over sine theta. That is the angle facing PQ. You have the sine rule in this form. This implies that 3.23 for TQ over sine 30 degrees equal to PQ, that is 6 over sine theta. You make sine theta the subject, you multiply by this and divide by this term. That is what you have here. If you simplify, you have 0.92879. To get theta, you check the inverse of tangent of this value, and that gives 68.2 degrees. So therefore alpha is also equal to 68.2 degrees. So we are back here. This is a right angle triangle, so height is opposite, this is hypotenuse. We must talk about sine. So you have sine alpha, that is sine 68.2 degrees equal to opposite h over hypotenuse 6. You make h the subject, you simply multiply this way, and you have height equal to 6 times sine 68.2, sine 68.2. If you multiply sine 68.2 by 6, you have 5.57 centimeters. Back to the area of the trapezium. The formula is this. You have parallel side, their sum is this, then times the height. So you have 1 over 2. If you add the parallel sides, you have 11.305 times the height. So everything simplifies to this. When you divide, you have 31.4844. To the nearest whole number, you have 31 square centimeters as the area of TQROS. Pythagoras simplified maths. If you are viewing and watching from YouTube, don't forget to subscribe, like and share PSM videos. If you are viewing and watching from Facebook, follow and like the page. Also share PSM videos.